So we're looking at worksheet 1.2. A few things I'm going to say. Tomorrow, so we'll cover 1.3 today. We have a quiz from 1.1 to 1.3 tomorrow. You'll do fine. It's nothing hard yet. I know, we just started. This Hamill's fault. But we'll get there. I'll make sure you're prepared for it. We'll review the whole thing, all answers and everything beforehand, and then I'll give it to you. I'm just kidding. All right, problem number 1. What is the probability of flipping a coin 5 straight times and getting heads on all 5? So it's a 1.5 probability of the first time. So it's 1/2 to the 5th power, or 1/2 times 1/2 times 1/2, 1/2, 1/2. So 1 over 32. So you have a 1 out of 32 probability of getting a heads. That means there are 31 outcomes that aren't all 5 heads. I want you to kind of start thinking about that too. Problem number 2, what is the probability of rolling 4 dice and getting a 6 on each of them? Well, you have a 1 in 6 probability on 1 dice, so it's 1 out of 6, so it means there's 4 dice to the 4th power, or 1 out of 6 times 1 out of 6 times 1 out of 6. Am I doing the right one? Yep. Okay, times 1 out of 6. So 6 times 6 is 36, times another 6 is 216. Times another 6, is that 10? No. What is 1,096? So 1 over 109. 1296. So 1 over 1296. Sound good? Like that? Yeah, that means that of the 1296, that means there's 1295 other combinations that could happen. For the 2013-14 season, LeBron James made 74% of his free throws. Assuming each free throw is independent, find for the next 10 free throws. So that's 0.74, it's the same thing as 74%. So I'm going to go 0.74 raised to the 10th power, and I know that's going to be an extremely small number. Does somebody have a value that they want to share? What'd you get? What? 0.049? Someone have a second on that? Just because I haven't done it. Does that sound good? Okay. So that's pretty. It's pretty unlikely he makes the next 10 in a row because he's got a 74% probability. What's the probability he will miss the next 10? So take whatever that answer was that you just gave me, go 1 minus whatever that answer is. So you're taking the complement. So it's 0.951. So 95% chance. Oh, wait. Wrong. I think I'm going the wrong way on that. Hang on, I gotta write this down. Why is this chair? So that means that his probability is this raised to the 10th. That's what we'd have to go with. Because it's a 26 probability. We want to know that he will miss his next 10. Well, it's a 26% chance he will miss the first one, and then it's 0.26 to the 10th. And what's that? Do what?
26. It's like the inverse of this. 0.26 to 10th is
0.26 raised to the 10th power. 2, 3, 4, 5. That's basically the chance that he'll miss this next 10. It is not the complement necessarily. It would, yeah. So he had this of making his next free throw. Of not making it is this, which is 26%. So then I took 26%, which is 0.26, and raised that to the 10th power. It's not the complement of, right. So 0.74 raised to the 10th power was that. If I go 1, so go store x, enter 1 minus x. No, it was not. It's not the complement of all 10. Each event has to be independent. LeBron will either make his next 3 or miss his next 3 free throws. He will either
either make or miss. Ideas?
Wait, wouldn't it be 100% because he can only make or miss a shot? Is that like alternative?
So let's see. Let's see how this phrase. LeBron will either make his next three, so he'll either make 3 in a row, or he'll miss 3 in a row, and it's not a combination. But it's an or. But just what's the chance that he either makes all 3 in a row, or misses all 3 in a row? It's one or the other. Okay? So I'm going to do 0.74 raised to the third, and that's the probability he makes all 3 next in a row. And then I'm also going to realize that 0.26 raised to the third is missing the next 3 in a row. Do you agree with that? So 0.74 raised to the third. So this is going to be, that's the probability. So he's got a 40% chance of making the next 3 free shots all in a row. Oops. Come on. Raise to the third. 42%. And 0.017576. So think about this. Think about this. So something to this. If I was going to do something 3 times, and it either is or it isn't going to happen. It could be make. That's one of the outcomes. Make, miss. One of the outcomes. Make, miss. One of the outcomes. Miss. One of the outcomes. Make, miss. One of the outcomes. Miss, make. That's basically what we're going through, as far as our combinations of events. So what I should do is I need to add these 2 together. So I'm taking the probability of making all 3, or I'm taking the probability of missing all 3, and I just want to know what's the chance that I either make them all or miss them all. And I'm going to add those together, which is about 41%, a little bit more than 41%. 42.28. So 0.4228. Okay. Does that make sense? So we're taking the probability he does all 3 make, probability that he makes all 3 miss. What's the chance he does this or this? I have to add the 2 events together. License plates in Colorado are made up of 3 letters followed by 3 numbers, like EFT673. Is that anyone's plate number? Good. Assume the letters and numbers are assigned randomly. Find the probability that you will get exactly the license plate A 111. But they say that you have EFT 673. This is one of the plates. Okay. So I want to talk about 2 different things that stem from this problem. This is going to probably ruin you for the rest of your life on statistics right now. Do you know the probability of getting AAA111 is the exact same as the probability of getting the probability of DFT673? Think about that. So your license plate on your car that you've driven or your parents drive, unless it's a vanity plate where you're like, I want to have, happy kid or whatever I don't know what your plate's going to be. One of my best friends, his name's Scott Schindler. When we were in high school, he was spoiled, which I was as well. So don't feel bad for me. His license plate, and he was able to get it through the DMV, and he had to explain to it, the DMV, this is the plate he wants because he's a golfer. I know this is off subject. I'm sorry, I'm off task. Scott's license plate was this. And he explained to them he was a golfer, which he was. But what's his license plate? Okay, no. You're right saying that, but 12 party, you're real close. 1 to party. But he told DMV, no, I'm a golfer. Like, oh yeah, that's great for her. I want to par off the tee. He just made it up. It was not what his vanity plate was going for. He wanted the vanity plate 1 to party. So he's a 16-year-old kid driving around. He had a Toyota 4x4 pickup with that license plate. And people are like, what does 12 part mean? That's just kind of funny. Sorry, I was off task. I didn't mean to get off task. It happens sometimes. It's pretty bad. So anyhow, if AAA 111 wasn't a vanity plate and DFT 673 was not a vanity plate, the probability of getting each one is the exact same, which is crazy. So, how many letters are there in the alphabet? And we're going to assume we can use all letters because I will tell you the license plate number is not going to do it. Well, how many? 24?
26.
He grew up in Parker. He lives in Parker. That's why. So you have a 1 out of 6 probability of you getting the letter A as your first letter. You have the probability, or 1 out of 26 is A being the second letter. You have 1 out of 26 is A being your third letter. So 1 out of 26 to the third power times how many singleton digits are there? 9 or 10?
10.
Why 10?
0.
Count the 0. Does that make sense? All right, so the probability of you getting a 1 as a single digit is 1 out of 10. Okay, and then, so actually, if we did the same exact thing here, this is the same probability that's going to take place. So this is going to be a pretty small number. I'm going to go 1/26 raised to the third. Oh, that's pretty small. I'm going to store that. And then I'm going to go 1 out of 10. That's 0.1 to the third. Is 0.001. So I'm going to go. Oops. So all the E means is this. On those calculators, it's going to carry it out to E. That's how the algorithm works. But what did you get for an answer? Tell me what your answer says. Yes, please. 5.68. Give me one more decimal, please. 9. What's your E? -5. Give me a couple more decimals. Okay, and then E to the what? -5. Okay, this is how your calculator does scientific notation. The E what this basically means, that's a point right here. This means 5.68 times 10 to the -5. So the -5 means we move the decimal 5 places to the left of where it's sitting. Okay, so I'm going to move it here, and then 2, 3, 4, 5. The decimal's going to go here. I have to fill in zeros there. So it's 0.000569 rounded. That's the probability that you would get that plate. Yeah.
I'm sure it's times better than 1 to 10. 32. That's just 1 to 26.
Oh, I didn't realize it wasn't multiplied. It wasn't the whole thing? Oh, okay. And then times 1 over 10, so it's 0.1 raised to the third is 0.001. Help me out. Well, I have to the -8. 1, 2, 3, 4, 5, 6, 7, 8. So that's probability you get the AAA 111. But you know what? You should all feel special about this because the license plate that's on the vehicle that you drive has the exact same probability of you getting that plate number. So you're all special in some way. Not everyone gets the AAA 111 or the 1-2 party, aka Scotty Schindler. Love that guy. Every day there is a 40% chance of rain in Honolulu. We're going to take a vacation for 5 days. What is the chance? What is the chance it won't rain on any of the 5 days? On any of the 5 days. Ooh, that's a little nastier. Yes. Yes. Both answers are fine. I will tell you what a lot of students will do. They ignore the E and they just write the decimal and then forget the E, and that's incorrect. So either write with the E or with the decimal. Both answers 100% correct. Does that help? Perfect. All right. You came in late. Remind me you came in late so I unmark you for being absent, okay? Is that okay? Tiger? Okay. I said your name right. Shake and verify it. Thanks, Shane. You got an A for the day. All right. A 40% chance of rain on any given day in Honolulu. We're going to take vacation for 5 days. What is the chance it won't rain on any of the 5 days? What is the chance it won't rain on any of the 5 days? That means that when you go to Hawaii, it's clear skies, right? What do you think? Go ahead. 0.6 to the what? Yeah, so this is the chance it will rain on an individual day. This is the chance it will not rain. So, being you're going to be there how many days? 5 days? 0.6 raised to the 5th power. So that means that you have free clear skies in Hawaii on your trip. And that comes out to what? 7.78%. Guess what? You're going to get rain on at least one of those days. I imagine a little more likely than not. In bowling, perfect game consists of 12 straight strikes. A professional bowler gets a strike 34% of the time. Seems kind of low. You're a professional golfer? That's worse than baseball statistics. Holy cow. Huh?
You're saying about baseball.
No, nothing. But it's like, hey, he's got a great batter average of .216. That means 21% of the times he gets a hit on base. I'm not trying to take things away. I'm just saying. All right. So 34% of the time, guy gets a strike. What is the probability he will bowl a perfect game? 0.34. Raise to the 12th. Whatever that comes out to would be your answer. So it's not very likely. You are to take a multiple choice test. Uh-oh, this is bad. This is bad. How many of you have ever taken a multiple choice test that was all true false? And you're like, dude, the worst I can get is 50%. Sorry. And then you get a test back going, how did I get a 31%? That's 50% slow. No. So, you're going to take a multiple choice test, A through D on each problem. Assume the test has 8 questions and you guess every question. So what is the probability you get every question wrong? Well, that's going to be 0.75 because there's 4 choices. 3 of the choices are wrong. So 3 out of the 4 choices are wrong, right? 0.75 raised to the 8th power. What is the probability you get every question right? Well, you have a 25% probability of getting them correct, raised to the 8th power. And then you will get at least 1 question right. Ooh. At least 1 question right. And I think we have to discuss this one a little bit more. So you agree with the first 2, yes? 8 questions, you're guessing on them all, you're like, dude, I can spell it AC/DC twice. That's a band for those of you guys that don't follow rock and roll. All right? And then for the lucky person in the room, dude, I'm just going to guess on the whole thing and get it all right. And then we want at least one question right. At least one question right. I'm going to build on this one a little bit. What do you think?
Wouldn't it be, if you're just trying to get at least one right, wouldn't it be 25%? Because that's the chance of getting one answer right, so then you have a 25% chance of getting one answer right.
At least one, so that means you can get 2, 3, 4, 5, or 6. Or at least one. You get at least one right, and the rest wrong.
You take one.
Is that right?
Minus the probability of you getting one. You take one minus the probability of getting everyone wrong.
Do what?
You take one minus the probability of getting everyone wrong.
One.
Minus the probability of getting everyone wrong, which is 10%. So you have 9% chance of getting this.
I just want to make sure that the verb's right. What is the probability we will get at least one right? So we're going for a 1 out of 10 on this bad boy. I think it's going to be this. 0.25. There's your right guess. You still with me? How many wrong guesses are we going to follow it by? 7. I think it's going to be that. So at least one right. So it doesn't matter if you get the first one right or the last one right or any of them in between, but at least one right.
That's too small a number.
Okay? Hang on, let's build on this. This would be one right only.
Yeah, and it's saying at least one right, so you could have one, two, you could have 3. So
Okay.
his reasoning makes
That's
sense.
too small of a number.
Okay, but that's for one right. Exactly one right, right?
But then it can be, but then it doesn't matter after that, because it just says at least one. So you just need to get one right, and then you're done.
One and done?
But then you can just guess, and then it doesn't matter, right?
But even on a guess, you could get one right.
It's saying at least.
At least,
that doesn't
means
matter.
that's exactly one.
Yeah, so that's wrong because
I know.
it means that you're getting one, yeah, 7 wrong.
Okay. So let's figure this out. Oh, I want to go here. I want to do this. All right. Shh.
And then you got one right, and the rest of it
Doesn't matter.
Yeah.
It's not only
The rest of
asking for one, it's asking for one or more.
One or
So
more.
if you get more right, it doesn't affect this
It's not
at least
asking.
one.
Yeah,
It's saying get at least one right. You only need to get one right.
I need to get at least one right.
That one's saying that you get 7 wrong, not just, that's saying
Yeah, what's the problem that you get at least one question right?
yeah.
Like
Least
that's
one
all
right.
you need to do. You just need to get one right. That's all it's asking.
But that's not the conclusion.
I know.
It's not saying.
You think it's 90%?
You get at least one correct.
Because you're saying that there's 10 questions or 8 questions.
You just take one minus the probability of everyone wrong.
So I got English majors in here. What does at least one mean?
You get one, and then you can go past that.
So you get the one and the rest is gravy.
Yes, if that's what the question is saying.
I think so.
It's like saying your goal is to get one right.
Get one right.
You have to get 3 right.
Okay. Okay, so how do you suggest we go through it if it's all in
Look at us, seriously.
So you think it's a 25% chance?
No, it has to be higher.
It's so high.
Yeah. I like it.
So it says at least one. If it said get only one right, then it would be referring to getting just one.
Okay, so this is only one right here, right? That's only one right. But we're saying we want to get at least one right.
What's the, what is the difference?
That's saying that you're getting 7 wrong.
Yeah, you're getting. No, but I'm trying to get the verbiage, and this is great argument for the class because the verbiage means everything in statistics. It's the literal meaning, and I'm meaning to ring your brains a little bit with it. I want to see if you can get it.
I mean, everybody guessed.
You know it.
What?
If they only wanted you to find out the probability of just one, it's high enough that you're going to get
I will tell you all that you are all on a nice close path, except for Parker Boy over here.
What did I do?
Nothing. This is a really complex situation. This problem, I'm going to say, probably was thrown at you too quickly in this class. This is a fourth month AP statistics question. Well, I'm just saying. Okay? And you're like, dude, we're not in AP stats. I know. But it's a healthy discussion what we just went with. So, you ready to see how this problem is done? You're not going to like it. You're not going to want to work it out. But if you were in AP statistics 4 months from now, you would be doing this one. You don't have to. I just watch. Okay, I think the key word is you get at least one right. That means you can get 2 right, 3 right, 4 right, 5 right, 6 right, 7 right, and 8 right. Ooh.
Did you say you think?
Yeah. That's a 7 there. And then we need to go 0.25 raised to the 8 because I think the terminology at least one right means you can get more than one right. Huh? So, 0.7 or 0.25 to the 8. Because 0.25.
It was in numeric order that went back.
Oh, yeah. I'm sorry, you're right. And then, to answer that question, to build one more, this needs to be 0.75 raised to the 0 power, which some people are going to say, but that's 0. No, something raised to the 0 power other than 0 is equal to what? 1. That's why they want it. I know. They three. I'm with you. So I think it was an error on our part in putting this together. But I will not hold you responsible for something like this. Next cupcake. That makes sense? So we made an error on our part. I would not put something like this that's difficult on. This is maybe like that, but not like, that's a lot of work. That's where your fingers are starting to get tired on your calculator and you forget. Let's see. Hang on. Who is this? Catherine O'Rourke. I got good news for you. I have a schedule here for you, and you still have me as a teacher. Or that might be bad news, depending on how you want to take it, especially after that last problem. So, again, guys and girls, please realize that kind of problem right there, this is where statistics really starts taking a bend. Because all of you had valid thought processes taking place. It was all critical thinking taking place, which I love. Because that's not, you're not just taking a coin and flipping it to make your decision. It's not an impulse decision. You took a little bit of your knowledge of what you knew of math and you applied it, and I love it. That's perfect. That's what the cool thing about math is. And you're like, dude, Stark, there's nothing cool about math. I disagree. I would agree with you if I was back in your shoes sitting at 16, 17, 18 years old in this classroom right now. But here's something, and those of you who had me last semester know this. Math is this and only this. You ready? Ready? Okay? Now, some of you are like, dude, we're seniors. If I would have known this way back then, I would have done something different in math. I will tell you right now, you would think for me as a math teacher that Mr. Silva might come up to me. Yeah. You have an 8-question test, A to D. Probability the kid gets at least one right. But he hasn't. And I've had many other administrators in my career. I've yet to have them come up and talk to me about this. So why do we learn the math? Why do we want to apply ourselves in math? And this is something that so many people don't think about. Because some of you, and this includes me, came across the F word real early in life. Fractions. And you shut off math right then and there. You're like, oh! And they told you things. You had an elementary school teacher, and I know that you all had the most incredible elementary school teachers. Okay? But the saddest thing sometimes with elementary school teachers, I say sometimes, is they don't know how to do math that well. And so all of a sudden, they're like, okay, you have 1/3 of a pizza and 1/5 of another pizza. How much you have left? And I was always that kid going, I just want to eat the pizza. I don't care how much I have left. Okay, so some of you got to a point with fractions. You're like, why is he talking about fractions? This guy's way out on tangent. This is the thing. Math is a way for you and human beings to develop an exercise in your brain to allow you to think at a different level. That's it. We shouldn't call it math. We should call it, starting in kindergarten, think 1, think 2, think 3. And right now you should be in like think 12. That's all it is. That's all math is. It's a way for your brain to develop the synaptic responses and pathways in your brain to think at higher levels. You ever wonder how sometimes you might see people and you're like, how can that person be that dumb? I don't look at you guys that way ever. I promise I don't. But I look at the unfortunate things sometimes with other teachers where I'm going, not every kid should be in calculus. That's okay. Like, no, calculus is the way to do it. When I used to teach at Shack, it was horrible. One of the teachers there would gloat that his BC scores were higher than the state average, the district average, the national average. But you know what excited me so deeply about this particular teacher? He would start his BCCalc class with 40 students. And by the time the BCCalc test came around, he was down to 12 students. That saddens me. Because all of those kids that were taking that class had the prerequisite to lead to it, but this teacher's ego was, I'm going to chase as many lower students out of my class as possible. And that was B's and lower students out of my class as possible. So I can look like I am a fantastic teacher. And I didn't look at the statistics of this. I was like, yeah, you might have a 4.8 average on your BCCalc test, but you chased 79% of your students away. That's not teaching. But what he missed was teaching isn't about me. He missed that. He focused, everything was about him, and that let's eliminate this half and then these rows, and then I'm just going to teach this. And that's saddening. Because the math is a way for you to develop a higher level thinking skill in problems. Why is the Rubik's Cube hard? Because we don't see the pattern of how to do it. Are there people that do? You're like, yeah, you need a white and white on this side and blue over here, and then you do this flip, 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 twist, 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 and you're solved. And you're like, wow, I couldn't have done that. What else we got?
What's the answer?
To that? I don't know. I haven't worked it out yet. That's your. All right. So 7C is definitely a problem that you would not see in a test. 1 in every 4 scratch-off tickets wins a prize in the Colorado State Lottery. Find the probability that Mr. Gambler Dude will win his next 3 scratch tickets. Well, that's 1/4 or 0.25 raised to the third column. You meet 2 new friends at camp. Oh, that's special. Oh, it goes to camp. I like that. What is the probability that all 3 of you will share the same birthday?
Wait, what?
What's you meet 2 new friends at camp. You're like, dude, what's up? My birthday is December 30th. Anyone have a December 30th birthday? My birthday just happened. I didn't get cupcakes, cards, nothing from you guys. They're like, dude, we didn't even know you. Some of you did. Yeah, so it's 1 over 365. Let's ignore the leap year raised to the third column.
0.00002%.
Okay. Not very likely.
Wait, what did you do?
1 over 365
Yeah, I got it.
raised to the third column.
Oh, so I was close.
Yeah. All right, Jeannie is a bit forgetful and doesn't make a to-do list. The probability she forgets something she's supposed to do is 0.1. Tomorrow she intends on running 3 errands, all independent. Yeah. Huh?
When you're like, so with a fraction or whatever, do you square it or do you cube it? Because there's 3
And then make sure you put 1 over 365 in parentheses. I think it's a dumb question. What's the probability she forgets all 3 errands? So 0.1 raised to the third, so 0.01. What's the probability she remembers at least 1 of the 3 errands? This is going to be similar to that. So it's 0.1 times 0.9 raised to the second plus. So again, we're not going to do this. What's the probability she remembers the first errand but not the second or third? Oh, that's much easier. Yeah.
Can you multiply and do add these things together?
So if I said, what's the chance that it rains both Thursday and Friday? You would add. You'd have the probability of Thursday and the probability of Friday. You can add.
And then everything else you multiply.
Yeah. So and then it defined it back here, right on. So if they're disjoint, if one doesn't reflect the other, you add. If they overlap each other. So it'd be like this, Shay. Thursday and Friday. Let's say 0.4 and 0.8 are the chances. No, I take that back. If they're disjoint, so what's the probability of you pulling a king out of a deck of cards and rolling a 6? Those are disjoint. There's no relationship to them. But then where they would be multiplied would be, what's the probability you pull a 3 and a 5 out of the deck of cards if you're drawing 2 cards and you're not replacing? Okay. Hey, Jeannie has a 0.1 of forgetting, and then a 0.9 of not. So if you do that, that's the probability she forgets. She does the first errand and forgets the second and third. And then the IRS, oh, we love the IRS. The IRS reports among taxpayers audited 70% end up owing more money. Auditor randomly selects 12 tax returns and audits them. What is the probability of all 12 owing money? 0.7 raised to the 12. That comes out to some decimal. What is the probability that you actually, none of them owe money? So that's 0.3 raised to the 12. And what is the probability at least one of them did not owe money? And again, that's one of those nasty problems that I'm not going to work out right now. All right, I got time to lecture. You ready? Set? I'm going. Yeah, the next one will be in the book, so you will have to get the book by then. All right. So, if you know that 2 events are not disjoint from each other, So let's say I have event A, I have event B. The center is A and B. Okay? In order to get A and B to happen, you have to multiply the probability of A times the probability of B. You will find that. So if I wanted to know what is the probability of A or the probability of B happening, we're going to go with it. We're going to go this way. Probability of A or B. So A or B is this region. This here and this here as far as areas. Notice what I'm not including. The middle. I'm not including the overlapped region, right? So this is going to be the probability of A plus the probability of B minus the probability of A and B. And in order to get the probability of A and B, what do I have to do? I have to multiply the two events together. Okay? So that's the first thing we're going to touch upon. So, example, find the probability of rolling a 2 or an even number on one die. So what's the probability of rolling a 2 or an even number? First off, is 2 even? Okay? So what's the probability of rolling a 2? 1 out of 6. Do you agree with that? What's the probability of rolling an even? That's 3 out of 6. Do you agree with that? So if I overlap the 2, this is the 2 and even we're going to take into account. So I'm going to take the probability of this times the probability of this. So straight across, that's 3 over 36 minus, oh wait. I'm going to add those together. 4 over 6 minus 3 over 36. How did I get 4 over 6? I added the two events together, and now I'm going to subtract that they both would happen at the same time. So that multiply the two together is 3 over 36. So 4 over 36, 4 over 6 minus that, I need to get a common denominator, multiply top and bottom by 6. So I'm going to get, what, 24 over 36 minus 3 over 36 equals 21 over 36. Yes, you can reduce it if you'd like. I hate to say this, and I know most of you are going to cry yourselves to sleep, but I don't have the heart to give you the quiz tomorrow. Alex, you be okay? Do you need a phone a friend or anything? Okay. So, can I do this? Just because as I look around the room, I don't see that many of these green books. So can I make your homework to make sure that this book has been purchased and brought to class tomorrow?
That's good.
Is that it? Yeah. So if you've already done it, your homework's done. Is that cool? Can I do that? So make sure you have this book. Okay? Green book. Woo.